Welcome students. We now come to the basic concepts of displacement, velocity and acceleration. If you remember that we started our calculus part like this, we said that there are two axes. Say this is displacement, this is time, and the slope was referred as velocity because there is nothing that the slope is equal to the perpendicular by base. Similarly, if I consider velocity and time, then what I get is acceleration by the slope. Same way, the acceleration is nothing but velocity by time. So this is an approach which we call the mathematical approach, or the approach in terms of calculus notation, where we learn that the slope is nothing but the ratio of the perpendicular and base, and then we can go on to write these things in a differential form where we put v as ds by dt and where we put a as dv by dt. So things apart, we should now understand that what we mean by a displacement, a velocity and the acceleration, not in terms of this basic mathematics that we have already learned, but now also in terms some other terms. Now let us find out. When we come to displacement, we say that it is, say, there are 2 points here. Now the particle can travel like this, it can go like this, it can go like this, it can have numerous methods going from here to there. With the displacement, we consider the straight line path. So it is a minimum distance between two particles A and B, and that should be a straight line, not only a straight line. If I draw two lines here, then these angles should be 90 degrees. It should be 90 degrees to form this minimum distance. So that is very important, you see. Whenever we have two lines like this, you can cross over like this, you can cross over like this, you can cross over like this, but the displacement remains this distance. There is a distance between the two shores, say when we are considering a river. So that is one very important aspect of displacement, is the minimum distance that we are traveling. And you can understand, I hope, that distance is always and always greater than displacement. Well, it can be equal to displacement, but it can't be less than displacement. In other words, displacement can never be greater than distance. So it can be put as displacement is always less than equal to distance. So that is one aspect which we have to learn very importantly. Now we come on to the next aspect where we consider velocity and acceleration. Now when I come to velocity and acceleration, I need to understand that velocity is nothing but the rate of change of displacement. So when I consider velocity as a point, then I consider it velocity, as we have already seen, as a ratio of displacement and time. And then velocity, as we can see, can be divided into two parts. That is, the first velocity which we have is that of uniform velocity. Now the uniform motion as a whole is non-existent. We rarely found uniform motion around us. So most of the motion is non-uniform, and this non-uniform motion is associated with various kinds of velocities, and the various kind of velocities that we have apart from uniform is the two, that is the average and the instantaneous. If I consider the average, it is simply adding up the velocities divided by their numbers, and the instantaneous is nothing but the calculus notation. So this is how we consider velocity in three different aspects. Same for acceleration. Same for acceleration. When we get to acceleration, we need to take the same thing. Same thing means acceleration also having two aspects. One is uniform and the other is non-uniform. So when you put it as uniform and when you put it as non-uniform, the non-uniform is again measured by these two parameters, which we call the average acceleration, and which the A we have is equal to dv by dt, which we call the instantaneous, and the uniform, as you can know, is A is v by t. So these are the various aspects what we learn about the uniform and non-uniform. Now from here on, we have to move on one more very important aspect which we need to discuss here, is the fact that when we talk about average velocity, the average velocity that we are talking about is nothing but simply the adding up of the two velocities that we are taking. Say for example, a particle, it moves from here and then it comes back there. Then in the distance it goes, it is, distance it comes back, it is. The velocity is v1, the time is t1. The velocity is v2, the time is t2. When I'm asking you the average, you see, it is a total distance by total time. So it is 2s divided by t1 plus t2. So that makes the whole thing topsy-turvy here. As we put it as 2s, and t can be put as t can be put as s by v. So we can put it as s by v1 and s by v2. So eventually what we get is 2 by v average, that is 1 by v1 plus 1 by v2. So this is the average velocity which we have 2 v1 v2 divided by v1 plus v2. Now this average, what we are talking about, is very important because this average is not simply v1 plus v2 by 2. So the question remains that when it is v1 plus v2 by 2, when the particle traverses two displacements, but the time interval remains same. So when the time interval remains same, the average velocity happens to be v1 plus v2 by 2. But the concept of average acceleration is completely different. Average acceleration is nothing but the change in velocity that we are having by the change in time. So the change in velocity, as you can see, it is a directional case. We will follow the addition of the velocity vectors in the method of relative motion. So that has to be taken care when we deal with average acceleration. So that's all now for students regarding displacement, velocity and acceleration. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.